Alright guys, in this video I am going to discuss about quick sort. Okay, to work with the quick sort we need three important things. One is swapping concept, next one is the midpoint, another one is pivot. Okay, because in quick sort we are going to divide the array and then we try to conquer it. But we do not divide and conquer the way we used to do in merge sort. So merge sort was different and this one is different. So in this one, we need swapping and partition at the same time. Okay, let's start working with this one. Okay, let's swapping method. Okay, swap. For swapping, we need one array and then int I and then int j. This one is public void. We need one temporary variable, tempy. Then after that I is now free. Okay, after I is free, inside that I, we are going to put in array in j index. Okay, and finally, what we are going to do, that array in j index, okay, comes from all that tempy. Okay, we collect there. So now we have this swapping method is ready for the array. This is dividing. I'm just trying to divide into three parts and then try to simplify it. Now let's try to partition it. Static int and then partition. Partition means that break it. And what we need one array for that as well. Left side, which is the 0 index, and then next one is right side index of the array. Now with this, we need to find out one midpoint, which is the not real midpoint at this time, which is still false because it keeps moving, but we need it. Let's give the name pivot from the right of this array. You might be wondering why we are taking from the right side. There are ways to create pivot. There are three ways. One is from left side, next one is from right side, and next one is from the mid one. But in Java, if you write code from the mid, then you are going to write more line of code. That's why people prefer left side or right side. Both are equal. Okay, so at this time, I'm doing from right side. Now, once I have pivot, then what I do, I need one variable, one index, which we are going to increment later. For now, that is I. And then int j equals, as usual, this is just normal for loop. This j equals left. Left at this time is 0, as long as left less than right. So j plus plus, all right? This is all as usual. Now let's try to compare it, okay? If the array in j index less than the pivot. If this array in j index less than this pivot, because we are going to compare this, okay? Pivot, then do what? Then do important thing, okay? You need to increment this I here, I plus plus. Then after swapping, if the j index is less than pivot, always I plus plus and then swap. If it is not, then ignore it. Okay, let's do one thing. Actually, this one is left minus 1. Otherwise, it will be same index. So swap. So swapping with what? The same array. This array is coming here for swapping because this is method call. Okay. Then after, and this I, swapping with this I, okay? Now this I is in 0 position, and then the j comes from here, this j. This job is done here. Now once this is swapped, a lot of thing is done now. Now next one is you need to do one thing. Next swapping is necessary here because this is the real index of that midpoint, the real pivot, okay? So I plus 1, and then I need right, this right. Now, to return I plus 1 here. Once this is done, actually I need to do this one here. You can do this here or you can do this here. So I'm just returning this I plus 1. That's why I'm not going to do this one here. Let me create another method here. Static void quick sort. And for quick sort, we need array int left and then int right. This is for quick sort. A base condition for this one. If left less than right. Now let's create the real midpoint, and that real midpoint every time comes from where? That partition. This one. This comes from over here. The main job of this whole partition is to create a real midpoint only. I need one array here. Array. Then after what I need here? Partition left and right. So there is a left and there is a right. And this partition, let me check it here. I'm calling this one out. Once this is done, then what you can do? You can do quick sort. Okay, you can call quick sort. Then the same thing, this array, okay, for a quick sort. And here, you need to do a couple of things, very important thing. You need to start from left, okay. Then after this mid, okay, you are running half, okay. Mid minus 1. This is one side, which is the left side, of the array, and next one is quick sort array. So mid plus 1 to right, and everything is done. Let me call this one here. Let me create one array here, and then let us create some random numbers. First, let's print this one, original one. Array is the toString, and then let me call this array. And now let me call quicksort. Left is 0, and then right means right minus 1. That means this array dot length minus 1. Then once we call this one, let's check if that is sorted out or not. Arrays dot toString, so array. It looks cool now, so let me check if it is running or not. All right, okay. Let me run it. So something is wrong here, index 15, 25, 23. 15, let's go to 15 first. By mistake, I type left, okay? Now it should work, okay? Let me save it and then let me run it. Let me make it bigger. So we have, this is original array, and then we have now, this one is the sorted array by quick sort. So minus 3, 0, 2, 3, 5, 6, 8, 45, and 54. So this is the structure of quick sort. What we did here, we created one swapping method separately, and then one partisan method separately to create the pivot. Finally, what we did, the sorting things, okay, using the quick sort, and that is the recursive. We call 2 times this quick sort, one for the partisan left and next one is partisan right. This is the basic structure of quick sort. Hope this is clear. Thank you.